A bitwise operator processes each bit of the binary value of an operand. There are 6 bitwise operators as given in here. The AND operator, represented by a single ampersand. The OR operator, represented by a single vertical line or the pipe symbol. The NOT operator, represented by tilde. It is the same bitwise complement operator that we learned earlier. The XOR operator, represented by caret symbol. The right shift operator, represented by greater than. And finally we have the left shift operator, represented by less than. As we already know, in byte, or the 8 bits format, the decimal number like 1, is represented as a string of binary digits, 00000001. Bitwise operators act on each bit of the binary representation of a number. Here is an example of the bitwise left shift. The golden rule for a bitwise left shift is, from LHS, shift towards left, bit by bit. And then, from RHS, fill vacant spaces with zeros. So, if integer a equals 2, then cout a, bitwise left shift by 1, would give the output 4. To make it clear, I will now give you a simple visual demonstration. We declared a equals 2. And 2 is represented by the binary digits 00000010. Now, we have instructed a less than 1, which demands that a bitwise left shift of 1 bit has to be applied to the value 2 of the variable a. In simple terms, it means that all the bits that integer number 2 is made up of will be shifted towards left by 1 position. Note that when this happens, the value of existing number will change to a new number. So here, the bits shift position by 1 place towards the left. The leading digit gets deleted. Here, the leading digit is 0. It gets removed. By the rule, trailing bits that go vacant are filled with zeros. So, the trailing bit space is filled with a 0. Now, 00000100 is the binary representation of the integer 4. So, final result is 4. Similarly, integer 3 has binary format 00000011. A bitwise left shift of 2 bits would make it 00001100. And this is the binary format of number 12. You can have a quick look at all the bitwise operators in this chart. I have given an example for each one of them and I am sure it will help you. Refer to the table with the sample values for P as 10, having binary format 00001010. And we also have Q as 4, with binary format 00000100. I will guide you in one of them. Take the first case. The bitwise AND operator. We have considered 2 sample values, P and Q. So, P, bitwise AND, Q will give the result, 0. How was that processed? Focus on the top right end of the screen. It would process just like how we add or subtract 2 numbers. Binary formats of P and Q are written one below each other. The rightmost column of P and Q are processed first. Both have zeros in the rightmost column. So, here, 0 and 0 results in 0. Shifting to next left column, we have 1 of P and 0 of Q. So, 1 and 0 would again result in 0. Remember that in the AND operator, only 1 and 1 will result in 1. Rest will all be 0. So subsequently the entire columns of P and Q are processed, and finally we have 8 zeros as the binary representation. And this is the decimal number 0. Then we have the bitwise OR, where similar columns are processed for the OR operator. Here, if any digit is 1, then result will be 1. So, P or Q would result in 14. Next we have the bitwise NOT operator. It's simple. All 1s become 0s, and all 0s become 1s. So here, tilde of P becomes -11. We then have the XOR operator. Here, if any one of the bit is 1, then the result is 1, else it will be 0. Remember that in XOR operations, 2 ones would result in 0. Any 1 must be the binary 1. Here, I have used A equals 5 and B equals 3. So A XOR B results in 6. Try it out. Next two are the bitwise right shift and the bitwise left shift operators. We had seen how the bitwise left shift operator works in the demonstration. Same applies to the bitwise right shift, except that the bits shift positions to the right. Try working out on them yourself. It's fun. We will next have a look at our last topic in this chapter. Operator precedence. Operator precedence is the rule followed by programming languages in deciding the priority of operation for expressions having multiple operators. In the expression 7 plus 4 by 9, the multiplication operator asterisk is given first priority, followed by the addition operator plus. Hence, the expression 7 plus 4 asterisk 9 would evaluate in these steps. First step. 4 times 9 is equal to 36. Next step, 7 plus 36 is equal to 43. The precedence levels of operators can be restructured by grouping them using parenthesis or the round brackets. Grouping defines the precedence order in which operators are evaluated within an expression. For example, the expression 7 plus 4 asterisk 9 gives 43. After grouping it to 7 plus 4 asterisk 9, the answer would be 99. From greatest to lowest priority, the order of operator precedence follows the rules as specified in this chart. You can take a closer look at it. So we come to an end of this chapter. Hope you had a good idea of the operators. It applies to almost every programming language, except with a few changes here and there. If you have doubts, review the video once again. Clear your doubts. If you still have doubts, you can message me. Meet you in the next chapter. Until then, take care, and have a nice time.